Hello, everybody. Welcome to the April Rust Gamedev Meetup. Now, you might see that I don't have my webcam on. I'm not sure why it's not working right now, but it's okay because I have a picture of myself in the slides. So this is the Rust Gamedev Meetup. This is also a reminder that this is Rust, the language, not Rust, the video game. And so if you are here to learn about code, that is very cool. But if you're here to watch me play Rust, unfortunately, that is not what is going to happen today. First of all, welcome. I am your host. My name is Forrest. I'm a student in Ottawa, Canada. I work on a game called Valoran in Rust, and I'm the co-host of the Rust Gamedev podcast. And I started running these meetups a few months ago because I think it's a great opportunity for people in the community to be able to come together and show off what they've been working on for the last month and kind of give a platform to that. And so how it works is we have three different sections. We sort of have like the show and tell, which will be what is streamed here. But also I want you to know that you can join in on the conversation on Discord. And so within Discord, we have our meetup channels here. I'll be keeping an eye on the chat, both on Twitch and on Discord, and we'll be making sure that any questions I could put in there are passed on to the people that are presenting. And then the other benefit about coming to the Rust Gamedev server is that you can check out everything that is going on in the ecosystem throughout the month. And so that's another big hope of kind of having this this ecosystem opportunity for the community. And so yeah, without much ado, we will get started on the show and tell. I'll be back in a second to try, just trying to get these technical difficulties with my webcam all sorted out, but it should be good momentarily. All right, so first up we have Aklisma, who's going to be talking to us about the profiling library. Aklisma, I just want to get you to speak for a second just so I can make sure I can hear you. No, but we are going to, well, it's working on Discord, but it's not working on Twitch, and so let me just get this sorted out quickly. Just trying to remember what I have done in the past. Ah, yes, it's because I need to change this over to Yeti. All right, can you start saying something again?
Is it working?
Hey, perfect. I think that's good. And then just if anybody's on Twitch, if they can just relay that you're able to hear Aklisma. But I think we're probably good to get started.
Cool. I'm going to mainly show the profiling trait today. I just published 1.0, and I'll use not Rust specific. This is general. There's instrumented profiling and there's sampling profiling. Instrumented is more accurate and lower overhead than sampling, but it requires manual markup of your code. So this is an example of the markup that this crate you would use. So you could either, this is an either or thing. So you could either mark up a function like this, or you could put a scope in wherever you'd like. And the beginning and end, the end of it is governed by whenever the scope drops out of scope as if it was a local variable. So sampling profiling would take thousands of snapshots of your stack, and it uses debug info to look up the symbols. So it can give you a lot of detail, and it doesn't require the manual markup, but it's also more overhead at runtime. Many profilers that do sampling profiling do actually let you do both. And if you instrument your code, it can actually improve the readability of your sampling profiling. So I'll give a couple of screenshots of some profilers that this supports. This one is called Optic, and you can see these scopes here. These are all manually instrumented by using the API that profiling provides. but this is also a sampling profiler. So you can see it goes into a lot of detail here, um, of all the functions that it's actually going through. These are collected by sampling, and this is collected by instrumentation. And then as another example, this is another profiler. This one's not free. It's called Superluminal, but it's very high quality. And you can see here, there's lots of detail. This is the sampling profiling here, but then these slightly darker blue scopes, this is from the manual markup. And using this crate lets you target both of these profilers plus a couple others. Tracy's a good one just because it's cross-platform. Most of the profiling stuff out there, not just for Rust but in general, is Windows only. But Tracy is cross-platform. So normally, if you want to do instrument profiling, you have to write specifically to the API that profiler gives you, and profiling wraps those APIs through macros so that it's okay. Cool. So yeah, so profiling exposes macros that wrap the underlying profiling API so that it's easy for you to switch between them. Because, for example, you may start off on Windows and be investigating something, and you put in the manual instrumentation for that profiler. Then, if you want to debug it on Linux, then you'd ordinarily would have to add that profiler specific API. So this wraps it. There's only 4 APIs here. These are all macros because if you don't enable the profiler, then it's as if this stuff doesn't even exist, and there's no dependencies in the crate if you don't enable the profiling. So this one is the scope, and that you can put in just as a like as if it's a local variable. This one's a proc macro around a function. This lets you register the current thread with a name so it shows up in the UI. And you would normally call this one once per frame, just so that it gives you kind of visualization of where a frame begins and ends. And WGPU has started using profiling, and I'm hopeful that if more crates adopt this library, then it will let people that are using popular libraries debug performance spikes and issues in their own applications. I'm going to just do a quick live demo so you can see how the capture works. So this is just a scene, and this is optic. So once you get them both running, you can just hit play, and it'll capture some frames, and you hit stop, and then you get all the information from that capture. You can see the frame rate smooth here. You can click on a single frame, and you can see that like rafx uses 2 threads. There's the main thread, which would be your application, and then there's the render thread where most of the work to draw is actually done. So in this case, you can see in this profile, most of the time is spent here in acquire next image. That's just waiting on the swap chain to flip because in this case, we're GPU bound. Were there any questions about that?
I don't see in the chat just yet. One second, I'm just gonna change over so I have my video camera here. Yeah, so I've recently taken a look at profiling just for kind of playing around and seeing how it works and stuff like that. And I think that I find it super cool just because like it's like very like lightweight. I kind of just integrated with a few things and it seemed to work pretty nicely. But then the one thing that I found a little bit discouraging was the ecosystem behind like the like I'm not sure what you would call it, like optic or superliminal, I believe, but like those types of technology. And so do you think that there is like a lot of potential in that area for like a maybe one that's like written in Rust, or maybe like somewhere in there that there's a lot of paid stuff, there's a lot of like C++ stuff, but it would be cool to have something maybe in like a different avenue of that ecosystem?
Yeah, so I guess there's a few aspects of it. One is that for a profile to be good, you need a good UI, and Rust is a bit weak on the UI options in the ecosystem. So I think it's actually ideal that you can use uh, you can do the capture with very lightweight code because you could potentially be capturing on an iPhone and then send that through a network connection to a profiler. And I don't think there's as much benefit to having the profiler UI itself being in Rust. I mean, it's great. I love things that are in Rust, but the main thing I think is that you can embed the actual profiler itself in lots of different applications very easily. There is an option in Rust itself called Puffin,
Mm.
and I actually have it in enabled because it's handy to be able to just jump in and see without having a profiler open. Like this is always available to just look at. The color choices aren't great. That's just out of the box, that the way it came. But and I don't know that it's very legible after it gets compressed and sent so other people can see it. But um, this does let you at least at a glance see what's going on without having to jump out into any other tools.
Hmm. Yeah, that's super cool. And I think another thing that I'm super excited about, not that, so again, like I think this is definitely going a little bit higher than like my knowledge grade of certain things within like our project. But with Valorant, we've been doing a lot of optimizations recently when it comes to networking and physics, and a lot of the stuff that we do on different threads, or the way that we are threading, I don't think we had as much information as we have started gaining started to gain recently. And so
Mhm.
I think that being able to like sort of like do this analysis on how the workloads are being distributed is super powerful. But I imagine that there's also a lot of technical difficulties when it comes to being able to identify problems when you're going through threading. And so, is there anything special that that you do to sort of handle this, or is it kind of just you're able to see every thread and you have to sort of make use of the or be able to understand the data yourself?
Yeah, it's definitely a skill you kind of have to learn. I will add one thing about profilers that are Rust specific. You'll see here, these are not, this is the mangled names that after Rust compiles it, passes to LLVM. So the symbol names here aren't very clean,
Hmm.
but Superluminal does have native Rust support um, and can clean up the symbols. So that is one area, I guess, where having native Rust integration is helpful. But as far as learning how to do profiling and application, uh, it's I think it's just the type of thing you have to do it. Um, so just as an example, a lot of times you may find some logging or some sort of a stall in one thread that it's happening because something else is flushing on another thread. So you would have to know to okay, you line things up, you look, and you say, oh, okay, well this is an IO thing, and I see this other IO thing going on, and like if it's flushing a log, and you've got another thing that's trying to log, and there's a lock that it needs to take to do that, then you can see that the spike came from logging, but it's not even that particular thread where the hitch is coming from. It's coming from some other thread that's holding a lock. But that's the type of thing where I think you just have to look at a lot of profile captures, and you kind of get a feel for where to look.
Yeah, so you kind of have to like play around with the data to be able to understand what's going on a little bit. Yeah, I think that's
Mm.
super cool. I'm taking a look at the chat here. I'm not sure. I think someone asked what was the name of the inbuilt profiler, and someone answered Puffin. And if I'm not mistaken, I think that's
Embark.
Embark. Yeah, that's working on that. Yeah, that's pretty cool.
Mhm.
Yeah, so I think going forward, I mean, I love seeing this kind of stuff. I love seeing data about the programs that we're running. And so I think that this is like an awesome project to keep up with.
Cool.
All
And
right.
while we're here, I just want to mention for rafx itself, I added um, tile map rendering, so you can use LDTK, which is a level editor,
Mm.
and export this and then render it out uh, in the UI. So yeah, more progress on graphics as well, but less to show this month.
And if I'm not mistaken, so rafx is a 3D and 2D engine.
Uh, it's it's pretty general because
Ah,
2D rendering these days is basically 3D rendering with an orthographic projection.
yeah, yeah.
So
Awesome.
yeah,
Yeah. Well, good to see the progress on rafx as well. It's always nice to see the different engines in the ecosystem moving forward. Um, someone just asked, does the Chrome DevTools profile or work with this as well?
no, I think the Chrome DevTools is a renderer for the data, so you would need something to do the capture. maybe that is integrated with profiling, and then you would use the Chrome tools to render it. But that yeah, profiling doesn't do anything but just mark up where the scopes begin and end.
Mm-hmm.
And but you can always use the. I think that's one key thing about the API design of profiling. You can always reach in and do whatever you need to do with an API of your choice, because the macros make it as if you would just put the instrumentation in yourself.
Mm.
So if you want to make a direct call to Puffin or Superluminal's API, you can do that.
I see. I see. Well, awesome. Thank you very much, Shaklisma. It was cool seeing the updates on this.
Cool. Thanks.
All right. So next up, we have Carlo, who's going to talk to us about Theta Wave.
Okay, so well, let me just watch the game here so we have a visual. Uh, so Theta was a space shooter game that I started making in 2019 with the Amethyst engine. It was sort of, for me, it was just, I wanted to learn the engine, so I just made a simple game. And uh, over time, I continued progress on this, and eventually it was chosen to be a showcase game for the engine. And after that, I was unable to work on it for a while because I'm, and still am in many ways an amateur programmer. And until then, I wasn't able to make much progress. And then I was joined, or I reached out to Mika after seeing her present at, I think it was, yeah, RustConf 2020. And she was willing to join the project. And I learned a lot from her about how to uh, code more efficiently and effectively and collaborate. And together we worked to refactor the project to be a more sensible structure and to conform better to ECS. Uh, and we also have been working to make the game more accessible to new contributors. So all of this work that we did together built up to a release we did last month called 0.1.4, the Foundations Update, which just named to symbolize how we've changed. It's like the foundation for all of the future uh, features that we're going to be able to add on now that the game is more sensibly structured. So I'll get into a demo right now. So this game is very inspired by a game called The Binding of Isaac. The game just got a new huge expansion recently, and in the game you progress through levels, acquire items to gain advantages, and items can synergize and build on top of each other. So I'll get started playing the game right now. So enemies right now spawn in. They can spawn either randomly or in formations, and you can shoot at them to destroy them. And the phases of a level are made up of a phase map that you can define in a RON file. So if I just pause this for a second, I can go to phases.ron, and we can see that the first phase is a 60-second formation phase with the level 1 easy pool of formations, which you can find here. And yeah, so you can define a level out of all these different types of phases, and uh, eventually we want to have, at the end, there's like a boss that spawns, then you can beat the boss and go to the next level. But right now our Here, I'll just keep it going in the background. I don't know if I'm going to play it, but just so you can see what happens. Right now, our MVP for this is we have sort of two MVPs. One is for this as a showcase game for the Amethyst engine. It's just to have multiple playable levels that demonstrate how to effectively use the Amethyst engine, and also demonstrate how others can add on and contribute to the game. And our second MVP that is much further in the future is we are considering forking this and then polishing it up and working with maybe a professional artist and sound designer to make a nice polished game that we can release as like an actual fun game. And we want to keep the open source game going because we've been really working to make it into a good entry point for new contributors. So, and that's sort of why we've been doing that, or why especially me I've felt strongly about doing that, is because before I started working with Mika, I didn't really know how to do contributions, how to make PRs, how to do code reviews, just because I didn't go to school for computer programming. It's not really something that I knew where to look, how to learn until I started working with Mika. So we really wanted to make it as a good entry point for new contributions. If we go to right now, the easiest contribution to make is you can go to, let me just pause this so it's not doing that. We can go to this spawner.ron, which is a data file for all of the formations and how they spawn. And the easiest contribution you can make is literally copy one of these entries as a formation, rearrange the enemies, make your own custom one, test it out, and you've made a contribution to the game. So we really want to enforce that it's can be super easy to make a contribution to this game, and we want to eventually write a book and documentation to sort of have different levels of contributions. So adding a formation would be like an easy one, adding a new item would be a harder one, and adding a new enemy would maybe be an even harder one. So yeah, that's I think a good summary of where the project is and what we're doing with it. So if anyone has any questions, I'll gladly answer.
Yeah, this is super cool. I love seeing sort of these like examples of how different engines can be used and stuff like that. And so you mentioned that you were like a new programmer when coming through this, and so for you to get up and running with like the Amethyst engine, how did you find like you learn through documentation versus like trying things on your own versus kind of like going out and finding or like learning more about the like Rust as a technology? Like what kind of worked for you?
So yeah, I had a very probably unusual uh very unusual path into Rust. So I started the first Rust programs I wrote were actually embedded, and it was I
Mhm.
had an engineering project at school, and they wanted us to write it in C, and I heard of Rust, and so I just asked the professor, "Can I write it in Rust?" And he's like, "Sure, yeah, if you can figure it out, go ahead." And I basically just blasted my way through that, and I didn't really know what was going on at the time. I didn't really understand why I should use Rust. Now I have a much better understanding of that, and yeah, then later I started looking into, okay, I want to learn Rust outside of embedded. So I started going to Gamedev, which is also a fun thing I like to do on the side. And I found Amethyst. And yeah, I think my path into Amethyst was I found they have like a demo Pong project, which I was able to get through. And a lot of uh, at the beginning when I was learning, I was working on Theta Wave, formerly called like Space Shooter RS, and I was just sort of wanting to add something and either try to find examples that had it that were maybe outdated. And sometimes it was a struggle, but I always would ask on the server if they have a Amethyst Discord server, I'd ask on if I couldn't figure it out, and usually I'd get a response and be able to figure it out from there. And now uh, Mika and I are realizing that we're at a position where we're sort of, we're the showcase game. We're the ones people are asking questions to. So we kind of, but now we sort of also have a better understanding of Amethyst, and we're able to usually figure things out on our own and when we want to add something new to the game.
Yeah, in chat it was mentioned that not sure if in game dev schools you learn much about these like the contributions, and I think I agree with this a lot. Where a lot of things about doing projects, especially like your own projects, are things that you have to learn through trying. And so I think it's definitely awesome that you're able to get up and running and come all the way through with this. And especially, yeah, kind of having that like rite of passage of starting in the Discord and asking around and getting like answers from people, but then being the person who's in a way like a leader within the ecosystem. I think that's one of the super powerful things about it is that you don't have to have a PhD to be the one that preaches all of the important knowledge about the engine and the language and everything like that, but instead we can kind of like make our own way there and build ourselves up to be people in the community, which I think is super powerful.
Yeah,
Um,
it's really helped me grow as a Rust programmer, because more recently, now that I've been using Rust for other things, I'm sort of reading through all the reading through the Rust programming language book, which is a lot of review that I know, but it's good to just read through that in order and make sure that I'm not missing anything, and using that knowledge to make the game more sensible and efficient.
Yeah, for sure. Yeah, it's something that I go back to quite often because I've never made it all the way through the entire thing, but going back to certain chapters is an incredibly helpful way to get where you need to be.
Yeah.
All right. Well, thank you very much, Carlo, for showing off.
Yeah. Yeah. Glad to be here.
So next up, we have Ekton here to talk to us about Cosmic Verge.
Hi, so I am trying to make a sandbox MMO in Rust, and I'm trying to do it as fully open source. I've presented it here 2 months now. It's still very early in development, although bits and pieces have been in development for a little over a year. I demoed this back in February and people joined, and it was fun to see a bunch of people hop in the game with me. Unfortunately, the game really hasn't changed much since then, but I have a lot to talk about regardless. Um, I wanted to kind of go back to some motivations of why I wanted to write a game in Rust. My story kind of starts with Rust, anyways. When I sold my company, my previous startup, I ran it for 10 years. And I sold it back in March of 2019. And about 6 months later, I quit my day job. And I had flexibility to pursue my interests a little bit. Eventually, I need to make some money. So I'm hopefully going to turn this into something that I can make money with. But, I was looking at my career, and the next best step for me, I felt like, was to essentially dive into Rust, because at the time I felt very confident that it was going to be one of the next big things. And I really feel like over the past year, we've seen a bunch of big adoption that has kind of proven that hunch correct. I don't think it was necessarily me being super, foretelling on it or anything like that. It's just it was pretty clear at that time that Rust was going to be pretty big. So beyond just wanting to use Rust to better myself and potentially make myself still have value at the end of me fooling around for a while, I also wanted to try to do something that doesn't require filthy monetization. There's too much of that in games these days, and so I'm going to try to do this in such a way that hopefully, like, a simple subscription fee is enough to sustain, a very small team to build something like this. And to make this be like a hypothetical dream job for me, which is what I really want, I also need it to be a community thing, because I hate doing stuff alone. And I've got some good news on that, because I've got another contributor now. So um, one of the first things that I've done in this past month is I've started an MD book to help me organize some of the game design stuff, as well as kind of giving a place for people to learn about the project, especially for people who aren't developers. I've been really starting to think about how to start getting people who are enthusiastic artists and musicians and things like that involved as well, even though I'm in very early. And part of it is just starting to build the framework of how to keep getting people involved, and that's kind of what this MD book is supposed to start. It's very early in progress. Stuff is very high level right now, but if you wanted to come check it out and learn a little bit more about Cosmic Verge itself, this is a good place to start. So what else have we been up to? I have a second contributor, as I mentioned, Dexpeda, which he was chatting in the meetup chat a little bit ago. And he started with me late in February, just shortly after the previous meetup. He actually discovered me completely independently. It was kind of funny. We've had a our Discord has been very useful with a lot of very long voice calls talking about architecture. He really wanted to start helping out with the back end. And I thought initially that sounded great because I can just keep working on the game. And, and what if I've been doing for the last 2 months working on the back end? So I wanted to start with analyzing what we were changing and why we're changing it. So what you saw in February and what that screenshot was powered by is was using a Postgres cluster for the reliable data storage, which I absolutely love Postgres. I'm a big fan of it. We also used Redis to synchronize our web servers and kind of do some backplane management because it kind of structures a traditional web app. And there's some various issues with kind of how this is all set up. But one of the key things I want to hammer is that I really do like Redis and Postgres. The downsides really come when we start talking about some of the deployment and trying to do reusable code. So the current approach, we use WebSockets, and TCP is just not great for games. A lot of people know that. I was thinking optimistically that I'd be happy to work around the limitations of using TCP. But after I had a contributor that was familiar with Quick, I decided that it would be good to actually use a better protocol. So I decided to essentially delegate that to him. And some of the other issues with our architecture with using Redis to do kind of a shared memory backplane of sorts is that the number of logged in pilots would increase the memory usage across the board. So if we ended up having 10,000 pilots in connected, that'd be 10,000 chunks of memory that we need alive on all servers and synchronized. And there's a bunch of different ways we could try to optimize various things, but essentially with the monolithic approach that I was going, there were going to be potential scaling limitations. Now, obviously this is supposed to be a hobby project. So before I get into some of the solutions, let me explain that both Dexpeda and I really like to do things right. And some of our other, motivations I'll talk about in a little bit. But one of the biggest things to us is we like to do things right. And so seeing these types of inefficiencies and ways to fix them means that we want to try to fix them. So the solutions, as I mentioned, Dexpeda started working on Quick. I started working on a new Rusty database, which I'll talk about in a minute. And then kind of we're building some other fundamental blocks, including kind of exploring building an async executor that supports some stuff that we'll use for cluster management, things like prioritization, being able to pin tasks. So the situations we're thinking about are, if you're familiar with the MMO like EVE Online, there's a system called JITA, which is a very popular trade hub. And something like that, it'd be very nice to be able to just be able to say, hey, this task needs more, like its own core essentially, or something like that, or multiple cores just assigned to that one system server. And that's the goal of where we want to be able to go. We're not going to necessarily build it all out to start with, but that's like the end goal of where we want to see. So we're trying to build our blocks to the point that if we want to get there someday, we can. So after kind of these building blocks have started getting going, we're going to finally write the game. So I want to talk a little bit about the actual database engine that I've started. One of the biggest things that I realized is that what the business that I sold after 10 years was built on was something called CouchDB. And it's a really strange NoSQL database that not a ton of people know about. At its core, it's powered by a powerful view system that it uses MapReduce at its core concept. And I connected the dots that essentially CouchDB just uses B trees in a clever way and exposes some really powerful functionality through that. And so I decided to try to do a hobby project of mine that I thought about for a long time, because there's actually a bunch of different implementations of CouchDB out there because it's an open protocol. And so people have written versions of it that live in JavaScript in the web browser. And so it's not too scary of an idea if you have a reliable storage model. But then the benefits of thinking about SLED in particular really stuck out to me in the sense that it's an ACID compliant transactional database engine. So some stuff that CouchDB doesn't support, I could actually build in that would make it a lot closer to a full relational database. So it's very early in development. I've only been working on it for a few weeks, but here's an example. Hopefully you've already kind of skimmed through this code, but this is a local storage example. So it's going to open up a database locally with this path, and then we're able to add a shape collection, which is just any serializable type, and then we get a result back which describes the document we inserted. Essentially, a document just wraps your data. There's an ID and some revision information. And then the goal of this is also to make it so that that same line that we use to push an object can be used in server mode as well. So this is the code. This is real code from an example on a development branch right now. It's not in main yet, of starting up a server and being able to create a database that's one line off. Create a database that's powered by this particular schema and use it remotely. So this is kind of the simplest example of the power that I want to have from being able to just use core traits of connections and be able to write code that's used once, both in a client and a server context. I don't want to go into too much detail because I know I'm getting pretty close to my time limit that I wanted to self-enforce on myself. But the biggest takeaway from this slide is that map reduce thing that we're calling views. And so I wanted to explore that over the next couple of slides. We're going to do an example. We're looking at two things you might want to do with something that was this shape. We might want to be able to query based on the number of sides. So I'm going to show two examples. One is how can I count the number of shapes that have a particular number of sides? And then the second example is how can I get a list of all the documents that match a specific number of sides? So those are the two very simple things we're going to jump through. To do that, we're going to define a view. And the first one is going to be a map view. And these are just associated types. It's a cool feature in Rust that not everyone's necessarily been exposed to too much, but it's how iterators are powered underneath the hood. And so for a map, for a view, for the map, we're going to have a key value, which is going to be U32. If we go back, oops, I clicked back. I'm sorry. There we go. If we were to go back to the other slide, the shape has number of sides is a U32. So that's what the key is here, because we're going to emit that as the key of this index. And the value is going to be U size, which is going to be the count. We're going to talk about how that actually works for the count on the next slide. Let's just look at how this map works. So you get a callback into your view for each document that matches whatever query is being run. And this is how you extract the shape back out of the document using serialization. It's all just kind of handled for you. And then if you want to emit a value, you emit a key and a value with shape sides, and that's going to be the U32, and the value is going to be 1. And all this is all strongly typed for you, all handled behind the scenes. To actually use that to get the docs, you can see we just do dbView number of sides with either 3 or 4 for triangles and quads, query with docs, and that's it. So for reducing, I'm going to go very quickly here. Essentially, you get an array of mappings, which are the same key values you just produced in the previous one, and your goal is to produce a value that is a single entity. So we're going to take an array of U sizes, and we're going to convert it into a single U size. And we're going to do that with just a simple iterator like we normally do and use sum. And so to actually use that on the client, you do triangle count, you view reduce at the very end. That gives you your U size. So I know I blazed through that really fast. So let me talk a little bit about the goals of this project. We really want to simplify development. That's one of the biggest things. For the current, if someone wanted to pick up Cosmic Verge today, they would have to install Postgres and Redis to get a development build running. And there's not really too much ways to make that easier if you want to actually use those databases. That's just a kind of a fact of life. You can add alternate database backends, but now you're making your code more complicated. Additionally, we see the ability to create like log aggregation backends using PliantDB in a reusable way, so that in theory we can share that between PliantDB and Cosmic Verge, and same with potentially the authorization and authentication schemes. I want to take a second just to say that we don't necessarily want to support those crates, so those will probably be internal crates for ourselves initially. I'm trying not to overextend how much I can support the community. So then I'm going to actually just kind of let the rest of the slide kind of speak for itself, because I can see that I'm a little bit past where I wanted to be on time. But the ultimate goal for what we're doing here is to try to replace both Redis and Postgres with PlantDB. And it's a big, lofty goal, but the project is moving along pretty well, and we're leveraging a lot of already built technologies in Rust that are making it a little bit easier for me to kind of get there. But it is very early in development, and there's a lot left to go. So I think that's a pretty good overview of what we've been working on. So these are kind of the ways to follow up with us if you want to learn more about Cosmic Verge or PlantDB.
Perfect. This is super cool. I'm a super big fan of like distributed computing and cloud computing and all of these like different ideas. And I think that one thing that I'm finding super cool with this is that so you definitely have like a scaling problem. You kind of know what constraints that you'll have within like sharing data and a lot of this kind of stuff. But within your constraints, you're able to like find that if you make your own solution, it might be pretty good for what you need. I think especially if you're coming from the background of already worked, like having worked on a database, then going through down this road is very cool. So sort of what I'm wondering is when it comes to like sort of these distributed systems and distributed clusters, have you do you sort of have like a game plan on like where you want to maybe restrict yourself, or is it more like you will try to create technology for anything that you'll need within the game?
So for PlantDB specifically, I'm trying to make what I want to use in a database engine whenever I create a hobby project. So yeah, there's going to be a simple job, queue system, and there's going to be pub sub support, stuff that I'm using in Redis today that I really want, and I feel is very useful when you're building an app. And if it's available to you, it changes how you want to write apps. And so some of that I just want to build up because I think that PlantDB stands on its own, and I want to be able to use it for random projects, even if they're features I don't necessarily want in Cosmic Verge. And that's kind of the key that I was trying to say, that like those logging and authentication ideas of reusable schemas, essentially, I want PlantDB to be something that the Rust community can use eventually. I don't think people should yet; it's experimental, but someday I would love for that to happen. Whereas those reusable schemas and stuff, I'm not sure if I really want to try to encourage people to build their businesses around those particular pieces, right? So PlantDB, I do want to be general purpose, and it will support things we're not necessarily going to use in Cosmic Verge. So for Cosmic Verge, we're going to try to use just the PlantDB clustering support for our actual cluster. We're going to try to build on top of that, as opposed to having two separate clusters, one for the database and one for Cosmic Verge. So that means that technically for Cosmic Verge, we're not going to use the kind of single database server model. We're going to have local storage for when you run it locally in your debugging and for CI. And then for the deployed stuff, we're going to have the clustered database engine.
I see, I see. We have a question in chat. What do you have in mind for persisting to disk in a bulletproof, durable way? And is that what SLED is for?
That's exactly what SLED is for. So yeah, I'm basically waving away one of this, and that's why I've been able to make so much progress in the last 3 weeks. Is just that SLED is a very mature project. So the biggest hiccups are just integrating in an async environment because it's not actually exposed as an async interface. But I'm pretty sure I handled that in as safe a way as possible. Yeah, so that's basically SLED is already guaranteeing ACID compliance. You can do things that trip you up if you don't guarantee flushing, for example. Right now, the default configuration is very safe, but there will be ways to kind of increase write performance, such as making it so that it flushes every so often, that sort of stuff. But that does increase data risk, right? So.
Mm-hmm.
And real quickly, I didn't actually write CouchDB. I just really used the heck out of it at my business. So I am very familiar with how it works because honestly, I mean, when you're programming your database by putting these views in it, you kind of have to understand when you're optimizing, why is this view slow? You have to really understand how it works. So I became very familiar with how to optimize CouchDB. I actually did meet Damian Katz a long time ago too, the founder of CouchDB. But I only used it as a consumer. I wasn't actually working on it.
I see, I see. All right, well, thank you very much. We have some claps in chat, so very cool, very cool.
Awesome.
Thank you very much, Acton. All right, so next up we have Dennis here to talk to us a little bit about WASM and threading.
Right. So WASM threading, it's an emotional journey. First of all, this presentation is provided as is without any warranty of any kind expressed or implied. And that is for good reason, because I'm not a web developer, and my friend with whom I started this project as our first Rust project isn't a web developer either. We don't like JavaScript, but we do like performance and low-level programming. So obviously, the ideal thing is to develop a browser web game. And yeah, that's how we got started. The idea was to heavily use multi-threading to increase performance, because we didn't want to write some game that is constrained by a single thread and doesn't scale well to modern computer systems. And in the web browser, there aren't native threads, so you have to use web workers, which are basically just JavaScript execution units. And you can also use shared memory, which is just an array buffer in which you can execute your WebAssembly code. WebAssembly is basically you can compile your Rust code into some bytecode format that the web browser executes, and it is often a lot faster than the just-in-time compiled JavaScript code. It also gives you predictable performance. And we didn't want to write JavaScript code for our game. And the last technology we're using is the off-screen canvas. You usually have to do every DOM interaction, every interaction with the web page from the web browser, from the main JavaScript thread, but if you want to do threading, you have to use something called an off-screen canvas. But I'll go into more detail with an architecture overview. So this is our basic approach. We have one main JavaScript script that handles the WebSocket connection, audio playback, and a simple fetch API, because those are all things that we can't do from web workers. It has to be done by the main thread, so we just factor those out. And everything else, we pass the messages by just basically writing into the shared memory buffer of our WebAssembly code. We read that via some sort of message queue. And on the top level, we have two threads. We have a logic worker that takes the input it received from the main thread, calculates game logic, the engine, and calculates on every tick the new sprite positions, puts that into one shared sprite buffer. And we have an asynchronous graphics worker that queries the sprite buffer and renders new frames, and also manages the off-screen canvas. The off-screen canvas is a special kind of thing. It's currently only supported in Chrome. It was supported in Firefox, but was disabled due to Spectre meltdown mitigations, and has not been re-enabled since. But we hope that this will be changed soon. But the graphics worker basically just takes the sprites, manages the video RAM, and renders them via WebGL. We will be switching to WebGPU in the future, but it does not seem to be mature enough yet. Doing things with, basically we have one slice of memory to load our program in. It is our whole address space. So we have to fit the stack, the heap, thread local storage, global data, everything into one slice of memory. And we made a few mistakes. First of all, don't be stupid. Because we wanted to optimize for size, we just tried out some WebAssembly optimization flags and accidentally just deleted our whole global data section, and were wondering why all of our global variables were initialized with 0, because they were just not included in the binary. And also we deleted all stack trace error messages, which made debugging even harder. So yeah, that's pretty much a given. Race conditions. Because we have one slice of memory, and we have, in our case, at least 8 threads that I'll come to that later, that all live in that one slice of memory. They usually all have, because it's also the same application binary, because we don't want to send multiple application binaries to reduce network overhead. So we just compile all programs of threads into one binary. But each thread has the same stack pointer. So the default behavior is that all threads start with a common stack and just constantly override each other's stack, which breaks very fast and was a bit tricky to resolve. And the third lesson learned, don't even trust your compiler. We had some super hard to figure out issues. We had basically racing conditions that only occurred sometimes. We stripped down a whole project into the bare minimum. Removing the WASM binding dependency seemed to help, so we still haven't re-added that. But we actually found out what the problem was. The Chromium compiler, the Chromium WebAssembly runtime, consists of 2 compilers. One basic interpreter that basically, as soon as it gets the WebAssembly code, it starts executing the code. And we have one optimizing compiler that's running in the background, and once it's finished, it takes over the execution. So we have this kind of tiered system to enable the code to be executed as soon as possible, but also provide a more optimized binary. And the first compiler that immediately starts execution didn't have support for atomics. So we had this compile time race condition that if your browser compiles your code fast, you don't get a race condition. And if it's too slow, your code breaks, which is hard to figure out. But now to the actual game. It's a 2D platforming game we started working on 2 years ago. And it's inspired by the game Nidhogg. We basically wanted to be able to send someone a link and then play a quick game of Nidhogg against them. We have a GitHub, and there's also a live demo. The live demo is a bit outdated, but this is the GitHub. We also have a Discord if you're interested in contributing or have questions about threading aspect, just hit us up. And this is the game. To be said, we're not game developers per se. All those graphics are hand-drawn by computer science students, so don't expect too much. For animations, for the engine, it's all self-written. We're just using the specs entity component system as a data backend. For animations, we basically parse the spine data format to display animations. And we're currently working on the physics engine and font rendering. But yeah, that's the basic setup. And I'd say that's it for now.
Perfect. This is pretty cool. We have a few questions here in chat. Oh yeah, first of all, someone mentioned it, but I love the programmer art. I think it's always awesome to see when you put stuff in. Oh wait, I'm muted on. Sorry, I'm muted on Discord. I was talking on stream, but there we go. I was gonna say I love the programmer art. It looks great. A few things from chat. When someone's wondering why do these APIs like the fetch and stuff like that you use from the JavaScript side, well with the WebSys you can do it within Rust.
Well, they tell you can do it within Rust, but you actually can't. What the WebSys thing basically does is that it exposes a function to Rust. You call that function, you call the JavaScript function, you allocate a JavaScript buffer, you do the JavaScript fetch call, and then it ports all the things back to Rust. The whole thing with WebSys is it's basically just a fancy wrapper to execute JavaScript calls from Rust, which adds additional overhead. So we opted to cleanly separate those things that would generate additional overhead, just factor them out. And also we couldn't do that because due to our layer structure, we can't use those functions from web workers, at least some of them. But yeah, the main idea was that we deprecated the WASM bindgen WebSys dependency and basically did the things ourselves and implemented our own message buffering to decrease latency and yeah, basically just the overhead. But I would not advise anyone else to do such. In the beginning, we had some issues with WASM bindgen, but that seems to be largely resolved by now.
I see. And then another question, is the character in your game wearing a mask?
Yeah, actually. That's actually
nice.
true.
Nice. Yeah, this is pretty cool. Yeah, so I think that's pretty much it on the question side. I'm trying to think if there's something else I'm wondering. I've been playing a little bit with sort of like WASM and doing stuff in the browser. And you mentioned that you're not necessarily like a
I have one more thing I totally forgot to talk about. We have threading. I can show you up here we have the thread pool. So one thing we did is that we can spawn web workers from our Rust code, and spawning web workers is kind of tricky because you load the program and then externally modify the program stack pointer to avoid executing it in the same memory space. But we basically implemented a wrapper for the Rayon. We basically implemented an implementation for our own Rayon thread pool. So we can use a completely multi-threaded ECS and spawn worklets off to other threads to execute work there. And yeah, that's pretty neat.
I see. Yeah, that is very cool. I think it was last month that there was some discussion that it's a lot harder to do threading on in WASM, but I think especially if you're able to wrap.
That was me that asked that question.
Nice. But if you made a wrapper around Rayon, is this something that you can look to push upstream into Rayon, or would it be something that you might make into your own crate separately?
It would be its own crate. The issue with the current setup is that we use atomics for the message communication. There are some similar projects that use message passing, so they use JavaScript post messages to synchronize the work between web workers, but that is not as performant as using atomic wait and atomic notify instructions, which are basically just cont vars. So we can use those atomic instructions to reduce the overhead of these threading solutions. So the main issue with our approach is that it requires some setup that is not easily integrated with current existing build systems such as Webpack. We would need to do that, but we haven't gotten around to it.
Yeah, and I think you mentioned your technique uses like manipulating the stack pointer to not override memory space, and that sounds like an interesting thing that I would not want to have to do if I was going to go about doing this. But yeah, all around, I think that this is super cool. Yeah, so I don't think I see anything else in chat here. So we do have some round of applause. So very cool, and thank you very much, Dennis. right, so next up we have Kevin here, who's going to talk to us about the current progress on Graphite.
As well as True Doctor, who has joined the project in the last month, as well as a few others that we'll talk about at the end. But starting out, progress since last month. We've gone from 0 lines of Rust code to over 1,500 lines. We've doubled the size of the Vue code base, so now we've added a lot more complexity in terms of actually having icons and buttons and SVG rendering. We've built the architecture skeleton in Rust, which also has a component that has WebAssembly that connects to the Vue instance that runs in the browser. When I say Vue, I'm referring to Vue.js, by the way, which is a JavaScript framework that we're using temporarily before we can have a proper user interface. We are now drawing SVGs in the viewport and using the browser's built-in SVG renderer to prevent us from having to write that ourselves at the moment, although we will have to write that eventually when we have our native renderer. We now have working select tools, a rectangle tool, and ellipse tools, and I'll show you briefly what that looks like. And then also we have set up a build system and a continuous integration system that is giving us a little bit more infrastructure for the project that we need to continue development. And also we've started out on some documentation. You can go and visit our documentation right now on the GitHub repository and start reading some information about the product manual itself for Graphite if you want to see how it will work as a product, as well as documentation for the code base, and then a separate documentation for the sort of the design ideas that we have going on, all the sort of UX design aspects of things. Those are the 3 areas of documentation we have. We came up with an architecture as well, and this is also a very big achievement in the last month. Basically, the way this is going to work is that we're designing it so that Graphite can be as useful as an ecosystem as possible to other projects. So game engines, for example, or basically if you're building a game, you might want to include Graphite as a renderer, and that way you can build you can render procedural textures at runtime. So I'm not sure if you see the mouse cursor. Can someone confirm? Okay, so we've got the renderer. Actually, I guess I can also do the laser pointer. Okay, even fancier. So you can build something like a game, and it can just depend directly on this Rust library that is the renderer, and it will be able to take any kind of GRD graph, which is basically a document that has been simplified, and it's just a thing describing how it'll render, and you can use it in the renderer. So that way you can make procedural textures, or even you could probably make your own game UI in Graphite, and then based upon certain parameters that you can feed in, like the current state of the UI or the name of your character to render in the UI or whatever text should be displayed, you can render stuff and then overlay it in your game, or use it as a texture in your game for any purpose. Then going up a level of the architecture, there will be a headless editor client. So basically it's a CLI version of Graphite that allows you to send commands and update the document. And this is the actual, like the main GDD file that you would normally edit things with the GUI client. But if you have any application that wants to use the headless editor, you're able to do that by just sending it commands through the CLI. Or you can include this as a library in your Rust project, and you can make your Rust project author the official Graphite design document files. And then finally, up one more level, we've got the editor library. This provides a set of utilities for providing front-end context to whatever client is working. So for example, we have our official editor. Right now it's web-based, so this is the first version we're working on as one of many possible front-end clients can use this editor library, and it keeps track of the state of everything that you need. It handles the tool system, so you're able to edit the document using tools. Basically everything that is needed to power a GUI-based editor is part of this library, and then you can have one of many editors. In our case, it is the web frontend, but we're going to replace the web frontend with a native frontend. But the other cool thing is that things, for example, other game engines or other 3D software could embed a Graphite editor themselves if they implemented it using the editor library. I know that the folks at Bevy on the Bevy project have discussed interest in Graphite being potentially some aspect of a plugin within Bevy. So this would allow them to basically make their own UI using the Graphite editor core library that puts the full features of the editor into, for example, one part of the Bevy editor. And that would allow people to seamlessly use both Bevy and Graphite to author their textures. Then we have our official actual client that we're working on right now. It's web-based, and eventually it'll be replaced with the second version, which is going to be native. So yes, that is the architecture. We also have a more detailed version if you want to go check out the documentation, or if you want to read the most recent Rust Gamedev newsletter that came out today. Feel free to check that out, and it's got a more detailed diagram that shows how all of the different parts of our actual code match up to this diagram here. So here is some progress since last month on the web front end. This is what it looked like a month ago, quite bare bones and very stripped down. We now have all of the tools. We also have a number of buttons up here for the tool options. We've got the color picker. We've got a much more fleshed out version of the tool hints. This is showing you your input events that you'll need to hit. These are all currently just static, but that's what it looks like now. This is what it was a month ago, and this is what it is today. And then additionally, here is some progress on the mockup. So this is the design that is a little bit ahead of the actual implementation that I just showed, but this is what it looked like a month ago. I showed this at the meetup last month. This is now a more polished version, which has some updates to the layer panel that look nicer and provide a better user experience. We have some new buttons up here that provide features for just turning on and off the overlays on the viewport. Just going back a month ago and how it is now, we've got some new features basically. Oh, and also the document zoom. So yeah, now it's time for a live demo. So, and if you want to do this yourself, you can go to editor.graphite.design in your browser, and you can try this yourself right now. So we have the viewport here, and we can now click and drag and create various rectangles. If you click on the rectangle tool or hit M for the rectangle tool, you can also go to the ellipse tool or hit E, and you can create various random shapes. And yeah, so this is what you can do right now. This is using the tool system that we built, which has under the hood a state machine going that is keeping track of the way that the editor works. And yeah, the colors are randomized for now, just so you can see that they're different.
Oh, and you can press Z to undo your last action.
Right.
Currently, the undo is tool specific.
I see. Oh, I can't actually go back. Well, yeah, I can. Except now I can't go back a little bit further. But yeah, some of these features regarding undo and the tool coloring and things are just quick placeholders that will be rewritten for a larger part of the architecture. But for the most part, this is a lot of progress. So yes, back
Awesome.
to the presentation. Again, you can go to editor.graphite.design if you want to play around with it right now. Feel free to do that. And also just want to welcome our new team members, True Doctor, who was just talking a moment ago, as well as Tom, or Tom Stone, and Async Theory, or Pro Theory, as he sometimes calls himself, and Geometric from the 2x library, the GUI library that he's working on called, I'm not exactly sure how to pronounce it, but 2x or Tweaks, and Rusty Nixie Tube. So welcome to our 5 new team members. It has been very helpful having additional support and making rapid progress in the last month. I'm very excited about the pace of development and how it will continue to expand from here. So if you want to join, either as a developer or if you just want to join our Discord server to lurk or to give some questions or suggestions, please jump on the Discord server. I think that'll be linked in the the current Discord chat for this presentation, or you can just go to www.graphite.design and then scroll down to the scroll down on the README of the of the GitHub repository's README file, and then it has a section for Discord. Please join us, whether you just want to keep track of progress, or if you're interested in giving some ideas or contributing code, please join our community. All right.
Perfect.
Any questions for either me or True Doctor?
Great to see the progress. I'll give you some from chat. So first one is it Electron used for the GUI editor app host?
It is not, and that's not currently the plan. Electron is rather heavy as opposed to lightweight, and that is not ideal. We are basically making it so you at the moment have to use your web browser, but we will then be aiming to replace that as soon as possible with a native client as soon as we have either a decent choice of GUI framework or we have the resources to write our own.
Awesome. I don't see too much else in chat, but I think seeing Graphite here for the last few months, it's been really awesome to see that you have like sort of like a little bit of a proof of concept of what you can do with the canvas right now, as well as like moving forward on like a lot of different fronts. So both with the front end, both with the Rust, but then also keeping like an overview of the architecture that you want to try and achieve and how you want to try and make it modular and be used for like as different plugins or like just the breakdown seems pretty cool.
Definitely, it's been a sort of a balancing act to work on both the near-term features that basically involves creating the features necessary for a SVG vector editor, while also keeping in mind the longer-term features that will actually make Graphite super distinct from all other editors by being fully procedural and fully non-destructive and node-based, and keeping basically making an architecture where we can work towards that final vision without ever making too much progress on something we have to throw away. We have to throw away a little bit of stuff here and there, specifically the web editor, but we're working within those constraints and finding the shortest path to the destination.
For sure. Well, Kevin, thank you very much for coming and showing us Graphite again this month, and I hope that next month we get to see even more.
Yes, I'm looking forward to it. The progress growing exponentially. It seems to have started on that trend so far this month.
Indeed. All right, so next up we have Kevin here, who's going to show us all his cubes.
Yeah. So as you might guess, this is a game that came out of, back in 2011, I was playing Minecraft and I said, I want this to be better. I want to do it my way. And so at that time, I wrote something I called cubes in JavaScript and WebGL, and this is now a version that I have rewritten from scratch in Rust. And so the core element of the game is that every block is composed not with textures but with voxels. So I call it the recursive block game because every block is composed of individual voxels. So like we can see that here is some extra grass, and you can see that we can So we can see that it is composed of elements, and I just got the smooth lighting working, and it's got some gaps in it because it is actually ray based rather than flood fill based. But anyway, so the goals of this project now are to basically, it's supposed to be a game which playing it is also how you make content for it, how you program it. So I haven't actually gotten these elements working, but eventually the blocks, the original vision was the blocks are programmed by adding elements inside the blocks, in analogous to Minecraft Redstone, of course, that define its behaviors. I'm not sure if I'm going to rebuild that strategy again, but the idea, because right now what I've gone for is the entire user interface of this game, except for the selection box, is actually itself built on voxels, as you might be able to tell from the perspective and the fact that the light element is shining on the rest of the user interface as well. Sorry if the frame rate's a little. I don't know, is the frame rate okay?
It's a little bit slow, but we for the most part we can see everything that's there.
Okay. So so it's still basically early work in progress. Every single one of these blocks that you see around here is procedurally generated, because I haven't yet gotten the actual interaction functions to the point where I can edit something and save out the block definition. And so I'm hoping to get that done very soon, and then I'll be able to actually draw. Then you will have programmer art instead of procedural programmer art. And so here's some basic terrain. Of course, that's the boring part. But it's become sort of a tinkering for of course one gets interested in graphics from. So you can see here that we have some transparent blocks, and this is actually not like something I originally invented, but this is actually a test bed for potentially migrating to a hybrid ray tracing system where the individual blocks, the individual voxels are actually ray traced in the GPU, but while there's still a mesh that defines the whole thing. And if that works, then we can have arbitrarily shaped transparency. Right now, it's only solid blocks, which could be a nice effect. Where was I? So the background is cross-platform, so it can actually run in the browser using WebGL. And it was interesting to see the previous talk about here's how we're doing threading in the browser. Like right now this is a completely single-threaded game, and the performance is not great. However, I think there's lots of room to optimize. I am not a game programming expert, and this is my very first project in Rust. So we'll see. This by the way, this here is just it was a test piece for multi-block structures, because as I said, since when I say that each block is made out of voxels, I mean that actually those voxels are stored in a three-dimensional space, just like the rest of this game. So this little bit of not work here is actually I haven't implemented the button to do it yet, but we could step into that space and edit it, and we would see this entire multi-block structure updates to match. And so and as you can see that I have text rendering, that again procedurally generating the blocks. And what I'm going to be doing is I'm going to be using this text rendering to. This is one of the elements of. There's going to be a full user interface with menus and pop-ups and so on. That is like this. The toolbar at the bottom here is of course just the very early version of that. And it's going to have the full interface built out of voxels. And so I was slightly inspired by the simulated voxel game Voxatron, if you're familiar with that. And so again, this is just a hobby project. It's got its gaps. I am open to contributions, but it's there's very much I'm still working on the architecture, so I think I'm running out of points that I want to make sure to cover, so maybe we can switch over to an interview format.
Yeah, for sure. I have a few things I'm wondering about. First of all, what's the tech stack that you're using within Rust?
Yes, of course. So basically, it is for the most part an implemented from scratch mechanism, and the one thing I have used a graphics library, the graphics library Luminance, which is based on OpenGL, though it may grow further backends. It's designed to be a high level type safe graphics interface, which is so you don't have to make sure to remember to make the correct sequence of calls and make sure you get your types right. There's no unsafe in using it. And it has WebGL backgrounds as well as OpenGL. This window that you're looking at right now, this is a desktop GL using GLFW. And for the rest of it, I'm basically using only, sort of data structure libraries, if you will, and I'm not using a game framework. This is basically intended to be its own framework. The core application, let me just switch the screen, see if I can switch the screen share.
For sure.
Let's see, where do I see? Sorry, how do I tell Firefox to change this?
Oh yeah, if it's Discord in Firefox, you should be able to choose the window that you want to see, I think.
Yeah, I just want to, let's see. Okay, is this working?
So it's thinking about it. It's loading up. Yeah, well, this is just coming along. Okay, wait, didn't go through that time, I think.
Yeah, for some reason it's not working with a desktop share. I have to pick a window.
Yeah, sometimes it is like that. Especially if you're on Linux.
Just a second.
Yeah, for sure. I'm just taking a look through some of the questions here in chat. One person was asking if you're running in debugger release mode in the demo.
That was actually debug mode. But most of the cost right now is the most of the cost right now is in the GPU, interestingly enough. So sorry, I think sorry, my good. Firefox setup. I only just enabled this, and okay. Let's see. All right, okay, is that working? No, it is not working. Okay, I was hoping to pop up the library documentation. I will actually, well...
Oh, if you want, I can take a look. I can open up my browser as well.
Yes, let me get the URL.
All right, perfect. Yeah.
Click. Okay.
So in chat said meetup without tech problems is not a true meetup. I have not been able to do stuff on my end ever properly. All right, here we go.
I just posted the link in the chat tab, and so that's the docs for a slightly old version, but you can see that this is intended to be usable as a library, but of course it's very much it hasn't been used as a library, but the idea is that if you wanted to do some procedural block generation and then render, if you wanted to do some 3D graphing or something, or draw something and then display it, you could use it for that.
Yeah.
So
I think there's definitely quite a lot right here from what I'm seeing, and I'll also put the link in chat for the repo itself.
Yeah. Yep. Let's see. And so there's some other things. Just for fun, one of the things I've done is I needed a ray casting system, so I actually just said, okay, let's make a ray tracer. So this is actually running inside. Or can you see it? Yeah.
It's loading up. It should be there in a second, I think.
It seems like it's okay. Let's see. Is it there?
Not just last time it seemed to take about 20 or 30 seconds, so we can see if
Okay.
it comes through. If not, we can just talk through it a little bit more.
And just see. Okay, just Firefox seems to be picky about which windows it'll show, so I actually just brought up the documentation window, which wasn't what I meant, but I actually built a ray tracer just because I can, and you can run it inside your terminal if you really want to. Of course, first-person controls work terribly inside the terminal, but it just this is as one does, this is turning into a bunch of like fun graphics side projects. But I'm trying to keep that down and actually build something. The future goals here, again, it's supposed to be an interactive voxel editor as well as the game. Or well, it's not a game in the sense that there's no game defined. You have to program the game. It's only like in the sense that like you play Minecraft, you can just build stuff, and some of the same stuff you can build will do things. That's the goal.
Yeah, I think I've seen
yes,
this idea quite a lot recently, in that it's sort of like within the game, you're given enough modification tools to be able to add your own content. And so I think there's something on like I feel like it's like the PS4 or something like that, where it's called like, I think Dreams or something, where you're able to make a game within a game. And I'm not sure too much about that, but and then as you mentioned, like in Minecraft, having the ability to kind of put logic in through Redstone. And so expanding on these ideas within a voxel world, I think is a great idea.
Right. So the original seed concept was I was building redstone machinery in Minecraft. I was getting annoyed by the fact that it was update order dependent. I said I can program better than that. And of course, it turns out that better than that is complicated, but I actually just started working on the core transactional update mechanism, which will make it possible to do that kind of thing. And in the screen share here, you can see a small piece of the data model that I have, which is the block. So basically, there's two fundamental categories of blocks. There are the atom blocks, which just have a color, though you could call them primitive voxels. And then there's the recursive blocks, which refer to a separately modifiable space which contains its own blocks. And then there's some other cases, like we can say we want to rotate one of these. We can say just this definition is actually stored is like a given block in a space can be defined inline, like if it's just this color, please, or you can have it defined as a reference to something else in this data file.
Interesting. So you can sort of add like almost like levels of functionality to any arbitrary block.
Right. Basically, the indirection. The purpose of the indirection is to be able to say, like you imagine, like I want a bunch of blocks that does this. I can copy this library into my world, and I have a bunch of definitions by which I can refer to by name, and then potentially you can like even say, okay, I want to upgrade and replace all of those definitions, and all the references to them will update. But it also means that any individual block can be just defined from scratch and exist in a space, and there's no concept of you have to give it an ID first.
Interesting.
So you can, if you want, you can have a collection of completely unique blocks. But of course, these are adding additional constraints to like the implementation architecture, and so juggling all of that along with Rust's mutability rules is getting a little interesting, but I'm not giving up hope on that yet.
Yeah, I imagine. All right, yeah, this is super cool. So I dropped the repo in the announcements chat. Anybody can go take a look if you like. And I think it would be really awesome to see like some improvements on this and kind of like the progression as the months go on. So I think there's definitely a lot here, but it's entering some really cool territory. So thank you very much, Kevin.
You're welcome.
Awesome.
Keep
right, so finally for today, we have Yazin, or Jamazazi, here to talk to us about MineWars.
Yeah, so during the last meetup, it was the first time I publicly mentioned the idea for this game, which has been brewing in my head for about a year, maybe more, year and a half. And I really started making progress on it after Bevy appeared, because the Bevy game engine really inspired me to actually do it. And so I've been working on it since then and made a few prototypes over the past few months. And now I'm announcing it publicly. A few days ago, I made a website, Twitter, and stuff. And basically, the concept is it's inspired by Minesweeper, but it's turned into a multiplayer real-time strategy game. So it's like Minesweeper, but if you step on a mine, you don't die permanently, you just get stunned. And you can capture those mines and you can move them around your territory to defend yourself, or you can trigger explosions with them to take out enemy mines. And all the digits update in real time, and you can expand your territory. And your cities produce mines for you. So you need to try to capture more cities and connect them, and you eliminate other players by capturing all their cities. So you try to be the last one standing. That's basically the premise of the game. And this video is the progress I made since on the latest version since last month. It's I'm kind of rewriting it because of lessons I learned from the previous playtests that I did. I made a prototype a few months ago that I played with some friends, and so now last month I had the basic rendering and the world generation, and now I have the basic mechanics, the basic exploration and capturing the territory. The rendering is better now with mipmaps and scaling and their camera controls. And I am trying to get this to a point where I can play it with people and make a public alpha release that we can all play. So hopefully, I don't know, maybe a month, however long it takes, to finish up the server and the remaining game mechanics. And yeah, that's basically the current state of the project.
Awesome. Yeah, so I remember last month, I think one thing that I am wondering is you mentioned that you're looking at redoing parts of the art because like you wanted like to have like an artist come in and do a pass on that. So am I remembering correctly on that?
Yeah, well, that's the plan, because eventually, hopefully, if the gameplay is actually good and exciting and I get a fan base for this game and stuff like that, I'm gonna want to eventually turn this into a commercial release that's like an esports like game. So with like spectating and replays and being able to watch live matches and competitive multiplayer matchmaking. So and if it's gonna become a game like that, it should probably have better art than my temporary placeholder programmer art. So I might overhaul it in 3D with an artist friend and make it look more like something like just for the sake of inspiration, let's pick something like Civ 5 or Civ 6 Civilization games, because they're kind of similar in that it's a procedurally generated world that's on a hexagonal grid.
Yeah, I think so. The reason I bring it up, and there's like several people typing in chat right now, but a lot of people are saying they really like the art as is, and it's sort of just surprising how nice it looks and minimalistic. And so I think the thing I wanted to add is, even though like definitely like there we can see like is programmer art in the sense of like is very like minimalistic. I think that's a great aesthetic for it. And so like and when I went to the website, actually wait, might just because I have dark mode on. No, okay, you do actually have a dark mode on the website. That's perfect.
The website is black because
yeah, okay.
actually I don't have transparency in the images, so I had to make it pure black.
Yeah, I mean, yeah. So what I'm thinking is that it's really cool to kind of see this as like an overview. And I think when I look at this looks like a game that is almost polished enough to like to be on Steam or something like that. And so I'm definitely excited to sort of see how the progress is going, and especially with this video of like sort of a bit of the gameplay. I think that it's definitely coming along quite well. And so yeah, don't be too worried about your art style. I think you're doing quite well with that.
Yeah, basically what you're seeing in this video, this is more or less representative of the early stage of a match. Like even in the real game, in the beginning, you still don't know where the other players are because you have the fog of war and everything. So you start with your starting city, and in the beginning you're kind of playing it kind of like a glorified Minesweeper game, trying to expand your territory and capture mines, capture resources, and find other cities and find other players. And when you encounter another player, yeah, as you can see in the video, you capture things in the game by surrounding them with your color on all sides. So if you think you know where a mine or a cluster of mines or a mountain cluster is, you can surround it on all sides with your color, and you capture that cluster.
And when it comes to some of the other sides of development, so you said you wanted to be like multiplayer. Have you worked on those systems at all?
Yeah, so the previous prototype was fully working multiplayer, which we could play with over the internet with my friends. So I have something which is as a prototype architecture that I can build on. That previous prototype was using TCP, but I'm gonna be redoing it with Quick for the protocol.
I see.
And yeah, and the game itself is hosted in the server, which is implemented in Tokyo, and the client is basically just a dumb client that displays things. It doesn't know like the mechanics. The server tells it what to display, and the client is in Bevy.
Nice. Yeah, it's definitely exciting with the 0.5 release of Bevy this month. Seeing the new stuff that's out on the horizon for it. Yeah, so I think that's pretty much it for questions. Is there anything else you want to mention about it?
Not that I can think of at the moment.
All right, perfect. Well, in that case, I am definitely excited to see where you get to next month as well.
Yes, one more thing.
Yes.
So now that I have the Twitter and the website, I want to post devlogs. I've already started writing them, so when I finish them up, I will post them and publish them so that you guys can.
Awesome.
I am working on a post about the screen shake effect, a post about implementing mipmaps for when you zoom out so that it can look nice, and a post about the map generation algorithm. Those are the three ones that I have in mind right now. We'll see what ideas I have later.
Perfect. Yeah, well, thank you very much, Jamadazi, for showing this off.
Yeah, well, thank you for organizing.
You bet. All right, so that is it for this month's Rust Gamedev Meetup. I have a few announcements to go through before the end right here. And again, just a reminder, if you want to present something next month, feel free to reach out to me. I love having nice and short little presentations. I love having longer form demos or anything like that. And so it's always good.
It's in.
Oh, wait, that's okay.
In our recent Secret Shopper series, Agent Sarah did.
I'm just gonna. All right, there we go. I'm sorry, my. Linus Tech Tips hopped in there for a second. All right. Yeah. So feel free to reach out to me if you want to present anything yourself, or if you have any announcements that you want me to put at the end of each of these segments. Rust Gamedev podcast, we have a couple recorded. We're working on getting them put out. The Rust Gamedev newsletter just came out today, so make sure to check that out. And actually, I'm going to put that up on the screen here for a second.
You seem to be muted, by the way.
Oh, yes, and now I muted myself in Discord. Okay, Twitch can hear me, and that's the important part because that's where I'm recording. But I'm sorry for Discord peeps. All right, so the Rust Gamedev Meetup just came out today. Lots of super cool stuff. So we got the MineWars up here. We got, I think I saw Theta Wave was here too. So make sure to go check this out. It's super awesome to see what everybody's doing in the community, and especially in this written form, you can see a lot about the dev blogs and everything like that that's going on. Now, other than that, that is it for this month. So thank you for showing up to the Rust Gamedev Meetup, and I will see you next time.